Cool. What kind of questions did you see on 13? Yeah, go ahead. On the first one or the second one? 7 on 15. Is it the one that's f at x equals 3x to the negative 3x to the third plus 15x squared plus minus 7? That one? Okay, yeah. All right, so problem number 7, and I gotta explain a few things on this one. Okay, so the fundamental theorem of algebra says this. It's the simplest thing out there. First off, what is my highest exponent in this problem? What's the biggest exponent? 2, 7, 15? What do you think? 3? Okay, so being that's the largest exponent, that means that we can have 3 roots or solutions. Okay, now what that means in the grand scheme of just math, and you do not need to know how to graph this at this point. Algebra 2 will cover it. This graph could look like this. And where it crosses the x-axis, those are called zeros. They're also called solutions. They're also called roots. All 3 of those pretty much mean the same thing. So that's technically what the graph looks like. And the reason why it would cross the x-axis 3 times is because it's raised to the 3rd power. Now, I'm going to give a term that says it could cross the x-axis 3 times, because this graph also could look something like this, where it only crosses once. Okay? But what you'll see in Algebra 2, dude. Stirrups mortuary, you stab them, we slab them. They didn't like me. Yeah. Yeah. Does that kind of make sense? Now, friends, the only thing that you have to know on this is this refers to that, and that's all. All the rest of the stuff below that blue line is bonus. Okay. All right. I'm sorry. It was on 15, and what number was it? 13. Okay. And again, this kind of goes along with it as well. So this looks like, okay, and they want to say, apply the fundamental algebra, theorem of algebra, for the total number of roots in the function. Okay, so if I look at this graph, and I know my graph doesn't look quite as nice as the one in the book, but it crosses 1, 2, 3, 4 times. This means it would be x to the 4th power. So we would have 4 roots. And again, I could call those solutions, and I could call them zeros. So you just have to look how many times it crosses, and that kind of tells you that. And there's a few other things that come with it, but this is kind of the basic. But in Algebra 2, you'll see where those graphs kind of do a little bit more. Any other questions off of 13 or 15 that you would like to see go over? We're okay? Life's all right? Okay, before I move on, so after today, that will put cohorts. You guys are cohort B, right? Okay. Sorry. Yeah. Okay, so this is Wednesday, Thursday, Friday. Okay. This lesson today will get us back on track. Actually, it gets cohort A back on track. You guys never left track. Okay? And then tomorrow we have some, or on Friday, I guess, for you all, we have more finishing up this chapter. And then for Monday, we have a review that I will do. I will give you the review on next time we have class. And then on Tuesday, Wednesday, we will have the chapter test. Okay? So I know a lot of people say, hey, what's going to be on the chapter test? It's anything from this chapter. My review will cover a great deal of it on Monday. So make sure on Monday, one, you have the notes that I will provide for you available. Make sure you are asking questions, but whatever is on the review is fair game to be on the test. Does that make sense? So I guess what I'm saying is, one, maybe take a look at questions you might have had on anything in this chapter and maybe kind of earmark it. If I cover that on Monday, that idea on Monday, then you're good. If I don't cover it on Monday, it might not be necessary to cover because it might not be on the test. Cool? And then Thursday, Friday before break, we start the new stuff. And then the Monday after break, after spring break, I will give you the notes for. So I'm saying, hey, you got to be responsible for holding on to a blank set of notes for 9 days. And then we do that. And then I have heard, it's just, things going around. So we have spring break. We'll have 1 week like this, like what we're doing now, where we have Monday remote, Tuesday, Thursday, Wednesday, Friday. And then we go back to 5 days a week. It might be 4 days a week where you are to come. So our school board and our superintendent and all the people who are making decisions, those are kind of some of the ideas that are coming back. So I just want to prepare you. I am not going to saturate you. Don't worry, I'm not going to be like, oh, sweet, now we can go real fast and get all caught up. You're in a good spot. So I'm not going to saturate you. Don't worry. You're not going to all of a sudden, other than having to start showing up 4 or 5 days, depending on what the school board chooses. And I don't know what the right decision is. I'm glad I'm not one of the people making those decisions. I'm just letting you know what's coming, what tentatively could coming. I feel pretty honored that I will have my second vaccine on Saturday. And now data is saying that after your second vaccine, within 7 days, they originally said it was 2 to 3 weeks. Now they're saying within 7 days, we should not, or me, having it shouldn't be somebody who could technically catch it, or if I did catch it, it would be a much lesser amount. But I've also heard that they should have about everybody nationwide fully vaccinated, if you choose to, by end of June, early July, which then would say we might have completely normal school in the fall. I'm excited about it. Now, I know all of you are, wonderful, great minds, and I will tell you that my daughter, who is a junior in high school, you're going to be jealous about this. She was involved in a study that started back in November to test what antibodies would look like with teenagers. She got $1,400 and is vaccinated. She would go down She got part of the study. I'm not sure how the lineage of events took place, but her and her friends had found out about the study, got involved in it, basically had to deal with her going and getting an examination that cost nothing, and they gave her a $100 Visa gift card. Then she goes in and they draw blood to test her blood. She gets a $100 Visa gift card. She then gets either the placebo or the actual first shot. They don't know. It could have been, it was a double-blind study. And they give her another $100 Visa gift card. Then she goes a week later, has blood drawn, another $100 gift card. Waits and goes the next week, gets blood drawn again, check antibodies, gets another $100 gift card. Third week, gets another actual vaccine or placebo. Again, it was a double-blind experiment. Gets another $100, and she's wound up getting 14 $100 Visa gift cards. Just think what you might do with $1,400 at your age. That's some walking around summer money. I don't know about y'all. That's good stuff. She's like, do I have to give you guys the money? I'm like, no. That's yours. But now we have found out she is fully vaccinated. So it's pretty cool. I can tell you I have not seen any reactions of my daughter, who is 17, maybe just a little bit older than you. So, I know that I would just encourage all of you to, and this is just a life situation, you make the decision that is best for you. It's really hard to decipher truth and non-truth in so many different things in today's day and age, because everybody and their cousin can broadcast their thoughts, ideas, opinions on so many different types of social media. I just need to let you know that I don't get two major parts of my life influenced by social media. I don't get my medical advice by social media, and I don't take financial advice off social media, because it's somebody's opinion, somebody's idea. Somebody read something on Facebook, therefore it's true. It's not. And I would strongly encourage you to please realize social media is real. It's around us all the time. But realize a lot of times it is for entertainment types of purposes. It should not be for how you are going to rearrange your life. Don't allow somebody to tell you something that, everyone has a friend that, I have a friend that did this. Now you're getting that directly onto your on a phone because a friend forwarded something that they saw from a friend of a friend of a friend of a friend, and there's no lineage of truth behind it. It's propaganda. So you do what's best for you. Do not allow somebody to bully you into you making a choice on what would be best for you. And really, when it comes down to it, it's really no one else's, business if you choose to get a vaccine or not. I'm happy to tell you that I'm getting one. I don't know. I've had my first vaccine. Have I changed in the last 3 weeks? Other than I get a snow day and I can't figure out this, them, or that. Yeah. Gotcha. All right. So that's my little soapbox for you. One thing that math, I've told you all, does, it allows you to think at a higher level. It allows you to critically think. So just know that a lot of times when you are being entertained by photographs that are being presented to you, or little snippets or little video clips, it's your entertainment. Okay? That's not your doctor that's posting it. Please feel free, if you have any questions about any of the stuff with COVID, please have your parents contact your your medical provider, your doctor. Heck, I don't know if you all know this, but if you go to the doctor at your age, you have the right to ask your parents not to be in the room. The doctor cannot disclose anything to your parents about you, any questions you had. The only time they can is if it's like you are talking about like a life-changing situation where you're having thoughts about hurting yourself or harming others. So you can, that conversation you have with a doctor or nurse, the doctor has to have your permission to tell your parents. And that's something that a lot of students don't know. And a lot of parents don't know that. A lot of parents get frustrated by that, going, I should know everything going on in my child's life. You know what? Sometimes kids aren't as willing to talk to mom and dad or grandma and grandpa or parent or guardian about something going on in their life. It is totally okay that if you ever go to a doctor's appointment, you can say, Mom, Dad, Grandma, Grandpa, parent, guardian, stay out here. I want to go in by myself. And that's a really weird thing to think about, but that is your right. And how do I know that? I have a number of my doctors in my medical class that teach it who tell that over and over and over again to our students. It's a real thing. All right, so you should have your note packet from this is like the second part of it. It says PEF number 16. So it looks like that. It's up on the board. Yeah.
I don't have those.
You didn't get the notes from? Were you here the other day?
I have 13.
13 and 15? Flip into it. It's a little bit further into the packet. It's 1, 2.
Okay.
It's about halfway in, maybe. It says PEF 16 at the top. Does that make sense?
Yeah.
Okay, cool. Does everybody else have it? Can you find it? Good, Judy, good. Selma, good? All right. All right, so we're still talking a little bit more about the zero product property. Okay, so remember this deals with, we're still factoring, but we're taking the factoring one step further. We're solving it. And that solving means where is it going to cross the x-axis? It's a solution if we graphed it, which gets into our next chapter, but we're not there yet. So item number 1, big difference up there is we have an equal sign. Does everyone feel comfortable? That is, it is not equal to 0 at this point. X squared plus 7x equals negative 10. Is negative 10 0? I don't think so. So what I'm going to do is I have to make it equal to 0 first. So what I'm going to do is I'm going to go ahead and add 10 to both sides. And I'm going to wind up getting x squared plus 7x plus 10 equals 0. Do you feel comfortable with that first move? Okay, did you find it? Okay. Okay. So from there, now I'm going to remember that it's equal to 0. We'll deal with that at the end. And we're going to go through and factor like we know. I'm going to look at this. I have 3 terms. I want to make it 4 terms. If my value in front of x squared is a number, great. If it's not, make sure you put a 1 and multiply 10 times 1. And I get positive 10. In order to get a positive number, it has to be positive, positive, or negative, negative. So we look to the other sign, and that tells us that they're both positive. If that was a negative 7, you would make them both negative, negative. Hey, friends, what two numbers when multiplied together to give me 10 would also add up to 7? Good. 2 and 5. Excellent. So 2 times 5 is indeed 10. 2x plus 5x is 7x. Okay, so I'm going to use that. Notice I didn't go through, I haven't done all the factors. I didn't do 1 and 10. So I'm trying to take us away from thinking about that. If you have to still list them, you're totally fine. You're not wrong. I'm just trying to take us away from it a little bit. Okay, so that's going to give me x squared plus 2x plus 5x plus 10. Need a pencil? If so, somebody left a box of them in here yesterday.
No, I got it.
Okay. All right, so if we look, I have an x in common. I had x plus 2. That sign comes straight down. I could factor a 5 out, get x plus 2. So it's going to give me x plus 2, x plus 5. But we knew in the very beginning it was equal to 0. So if you said x plus 2 equals 0 and x plus 5 equals 0, if you subtract 2 on this first one, I get negative 2. And if I subtract 5 on this one, I get negative 5. So negative 2 and negative 5. Those are my solutions. Those are my answers. Those are my zeros. Those are my roots. Notice I gave it a whole bunch of words because solutions, roots, zeros, they all mean the same thing. Is that okay? May I move to the next problem? It's equal to 0. Agree, friends? So I don't have to move anything over. Oh boy, I only have 2 terms though. Oh, if it's 2 terms, I was told if I have 2 perfect squares separated by a subtraction sign, I can just break it into 2 binomials with 1 sign different. So x squared is a perfect square. Agree? Is 3 times x a perfect square? No, I can't multiply the exact same number of times itself to get me 3. And that x, that's not a perfect square because that need x times x to give me x squared, or x squared times x squared to x to the 4th. So then I have to think, is there a different way I could maybe go about this? And I think I can. I have a greatest common factor of an x, and I have x minus 3. If I distributed that x back over, I'd get x times x is x squared, x times negative 3 is negative 3x. So that x by itself is going to be equal to 0. Then I'm going to go x minus 3 equals 0. Add 3 to both sides. And I get my 2 answers. Realize that's to the 2nd power. I should have 2 answers. Or I could have 2 answers. Good to go? All right, friends. Critical thinking time. What's my largest exponent up there? 3. So how many solutions, zeros, or roots should I have? 3. Make sense? Again, that's fundamental theorem of algebra. Okay, so we have 3 terms up there, but everything has a 4 and an x in common. So I'm going to look at my 3 terms, 1, 2, and 3, and I'm going to say I'm going to need to factor a 4 and an x out of all. If I factor a 4 and an x out of 4x to the 3rd, that leaves me x to the 2nd. If I factor, and the plus sign comes down, if I factor a 4 out of 8, I get 2. If I factor x out of x squared, I'm left with x. The subtraction sign stays there. If I subtract or factor out a 4 from 12, I get 3, and the x already comes out. We good so far? So I recognize that it's equal to 0. So I'm going to take 4x and say 4x equals 0. Divide each side by 4. Those cancel. 0 divided by 4 is 0. So that's one of our answers. You told me there's 3. So I have one of them so far. There's 2 more. So I'm going to look here, and I'm going to say I'm going to go ahead and factor that. Okay, I have 3 terms. I want to make it 4 terms. All right. If the value in front of x squared is a number, great. If not, put a 1. So we'll put a 1. And then negative 3 times 1 is negative 3. And we learned a long time ago that if we multiply 2 numbers together and it happens to be negative, One has to be positive, one has to be negative. Agree? So what are the factors of 3 that would add up to positive 2? What two numbers multiply together to give me 3? It's help. Positive 1 and negative 3. Let's see. I agree with the 1 and 3 totally. So let's think about this for a sec. I think you might have just flip-flopped them. If I go positive 1 and negative 3, if I added those together, that would make that a negative 2. So I'm going to flip-flop these signs. I'm going to make this a negative and that a positive. Because 3 minus 1 is 2, right? Cool. And then both of those are going to be an x. So I'll bring our x squared down. I bring plus 3x down. I could have brought minus 1x down too, but I just put it over here. See what I have in common here? I have an x in common. This negative needs to come down. I'm going to factor a negative 1 out. Signs change. So I'm left with x plus 3 and x minus 1. And we learned in the very beginning it's equal to 0, so I'm going to set each of those equal to 0. So I subtract 3 on the first one, add 1 on the second one. So you had told me originally on this problem that it was raised to the third power. So there's one solution, second solution, third solution. Solution can be a 0, could be a root. Seem okay? May I move on, friends? All right. Hey, next one. It is indeed equal to 0. I'm happy about that. I have 3 terms here. I want to make 3 terms 4 terms. If the value in front of x squared is a number, great. Great. If not, put a 1. So put a 1. Positive 6 times 1 is positive 6. I learned a long time ago that if I multiply 2 numbers together to get positive, it has to be the same sign. So we look here. That's going to tell us, yep, that'll give us the positive positive. Hey, what 2 factors of 6 add to 5? Yeah, Philip. 2 and 3. Excellent. 2 times 3 is indeed 6. 2 plus 3 is indeed 5. If you chose 6 and 1, those would add together to give me 7, right? So that's what I'm going to go ahead and use. So I'm going to bring down my x squared and whatever order I want, plus 2x plus 3x, and then bring down that 6. Take a look here. I have an x in common. This sign's positive. Looks like I can bring a 3 out in front of those. So we have x plus 2 and x plus 3. We're not done because it was equal to 0. So I'm going to set those equal to 0 and break them apart. Subtract 2. Subtract 3. Done, done, done. What do you think, friends? Seem like it's kind of flowing together a little bit? Okay, on this next problem. Let's see, what do I have left? I got this one, 2. All right, cool. This next problem, it's equal to 0. That's what we want. We don't have to move anything. I want to take my 3 terms, break it into 4 terms. If in front of x squared is a number, great. If not, put a 1. Multiply 42 times 1 to get positive 42. We learned a long time ago, when you multiply 2 numbers together to get a positive, it's either positive or negative negative. Well, that subtraction sign there is going to give us the hint that they're both negative. Agree? Okay, friends, what 2 numbers would multiply together to give me 42, both being negative, and would add up to 13. Judy. Very good. 6 and 7. 6 and 7. Notice again, I didn't write them all down. So -6 and -7, if I add them together, gives me -13. That's what I want. So we're going to bring down x squared minus 6x minus 7x plus 14, or 42, excuse me, I'm sorry. Looks like I have an x in common here, and that leaves me x minus 6. I have a negative here, so I'll bring that out. Looks like I can factor a -7 out, so that's going to change both those signs. Those are the same, which I want. Hold your horses. It was equal to 0, so I need to make those equal to 0. And then break them apart, set each of them equal to 0. Add 6. Add 7. There it is. Feeling comfortable? May I move on? Next problem. Ooh, I have only 2 terms. Okay, x squared is a perfect square because x times x is x squared. 1's a perfect square because 1 times 1 is 1. Is this a subtraction sign? Not this week. This one won't factor. Okay, it does indeed have a solution. You don't need to know what that solution is yet because you'll see it in Algebra 2. But the solution it actually has is part of, I kid you not, a number system called the imaginary number system. You don't have to know that. Yeah. It won't factor. If it was this, so same problem, I just changed that sign. This would break down to this. So difference of 2 squares. Difference meaning subtraction. But because that addition sign's there, means it will not factor. Okay? So this answer is part of the imaginary number system. Like, what kind of sick, demented person decided to say, let's name the number. We have so many number systems. We have the counting numbers. Thank you, Archimedes. We have the whole number system. That's the counting numbers, including zeros. Thank you, ancient Aztecs. We have the rational numbers. Any number that can be written as fraction. We have the irrational number system. That's any one that can't be written as a fraction. It's a decimal that doesn't repeat. We have the integers, which is the negatives and the positives, and 0. Those all encompass, I kid you not, the real number system. And then some mathematician who was a big jerk, bad sense of humor, goes, yes, we have the real number systems, all of these, but now we have the imaginary. How in the heck is society supposed to decipher this? It's like an Abbott and Costello. I don't know if you know that, but that's the who's on first, what's on second. I mean, those are seriously conversations. Like, no, your answer is imaginary. What do you mean? It's not real? That's correct. So it's imaginary. It's fake. No, it's imaginary. Isn't fake and imaginary the same thing? No. Imaginary is the name of the number system. Well, what's a real number? Everything that's not imaginary. What do you mean? Well, all the numbers that you know. That's part of the real number system. Of course they're real numbers. Aren't imaginary numbers real numbers? No, they're not part of the real number system. Like, what? Sometimes I hate math people. They're just mean. Okay, so we have 2 terms here. They do have an addition sign between them. I know that x squared is a perfect square, but 10x is not a perfect square. So I think I could factor an x out of both. And again, we have to remember those are equal to 0. Don't forget to say, hey, x is equal to 0. There's one of my answers. And then x plus 10 equals 0. So I'd subtract 10. There's my other answer. I know this kind of problem. This is how a lot of people do it. Like you kind of think, oh, I think I have it right. And then on the test, you go x equals 0 way, way up here in like 0.2 font. So I'm squinting. Write it with confidence. Yes, I know that x is equal to 0. It will work. X is also equal to negative 10. May I move on, friends? Okay, so, uh-oh. Is that one equal to 0? No. So I need to move that 12 over. So I'm going to subtract 12 from both sides. There aren't any like terms, so I just need to put it there as a placeholder. So I get that. It doesn't look like I have a greatest common factor because 2 doesn't go into 5, so that's not going to work. If my lead coefficient is a number, great, it is a number, it's a 2. So I'm going to multiply those two together. So negative 12 times 2 is negative 24. We learned a long time ago that when I multiply two numbers together to get a negative, one has to be positive, one has to be negative. Hey friends, what two numbers could I multiply together to get negative 24, one being positive, one being negative, and add together to give me negative 5? So 1 and 24, no. 2 and 12, no. 3 and 8? 3 and 8, are they 5 apart from each other? This week. So I have positive 3 and I have negative 8. Positive 3 times negative 8 is negative 24. If I add those together, I get that negative 5. Agree? So 2x squared, whatever order I want to write these, plus 3x minus 8x minus 12. So I have an x, 2x plus 3. There's a subtraction sign, and a factor of 4 out of both of those. Leaves me 2x minus 3. So I know that my answer is 2x plus 3, x minus 4. This, we made it equal to 0, so I'm going to bring equal 0 down. Do not bring the equals 12. You want to have it equal 0 once you move it. So then you're going to go 2x plus 3 equals 0, and x minus 4 equals 0. Well, that's just going to give me positive 4 because we add 4. This one I'd have to subtract 3 first. So I get 2x equals negative 3. And then I'm going to divide both sides by 2. So I get x equals negative 3 over 2. And you can go ahead and leave it as a improper fraction, meaning the top's bigger than the bottom. Last problem of the day. Can we do it? Ooh, we have 3 terms, but the middle term is a 0. Okay, well, let's see if we can figure out this. All right, so I'd have these 3 terms. Even though I have a 0, that's fine. The first number, if in front of x squared is a number, great, which it is. So I'm going to go negative 8 times 2 is negative 16. In order to get a negative number, one has to be positive, one has to be negative. Can anyone think of the 2 numbers that I can multiply together to give me negative 16 and add together to give me 0? What times what gives me 16? Judy? 4 and 4, excellent. So I have a positive 4x and a negative 4x. Bring these down, 2x squared plus 4x minus 8. I have a 2x in common here. I have a negative here and a 4. Signs change because I factored a negative out. Friends, it was equal to 0, so I'm going to set each of those equal to 0. So subtract 2. Let's see, add 4, divide by 2. There's my two answers, my friends. All right. This is PEF. Which one? 16? Is that what it is? So I already collected those. So PEF 16. We'll do every other odd. Sound good? Friends, it's time to go. Have a great day. Take care of one another. I look forward to seeing you all on Friday.